Okay, in the last class we studied till example number 4. Okay, in today's session we are going to start with example number 4 or example number 5, which
The
is
same
that,
type, right?
yes,
By parts.
yes, we are still on the integration by parts, because integration by parts is just requires lots of practice.
Okay.
We are going to spend today's session and we are going to do some questions from the book as well, because the examples were really easy. Well, let me connect my screen.
No problem.
Okay, the question is that calculate the integral of tan inverse x dx, and we have to evaluate it from 0 to 1. So far we were doing the questions where limit was not given. We have to just take the integral of a function and we hadn't any limit.
Okay.
But in this question, in example number 5, we have a limit. We have to integrate that function from 0 to 1. Those functions are called definite integrals.
Okay.
These questions were indefinite integrals. These are definite integrals. And the formula is the same. F of x, g of x, and then we have to apply the limit, which is 0 to 1, minus again the integral of g of x, f dash of x. The formula is the same, just we have to now substitute the limit. Okay, let's start it.
Okay. Okay. Just give me 1 second. Oh, I'm just going to change my share.
Okay, sure.
Do you need this?
Huh? لا 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 it is this.
Huh?
ايه سيف عدي صح؟ لحظة بس عندي كلاس انت جالس صح؟ اوكي اقول لك انا المفروض ما اشوف، بس انا شفت تليفونك انت مشغل كريبتو كرنسي صح؟ يعني بس تجي نشيت كان اشوف، بتكلم معك عقب عن هالموضوع. اوكي مو محتاجها صح؟ لا لا لا
Hello.
Hello, yes.
Hmm.
Okay, let's start.
Go ahead.
Okay. We have to take the integral of tan inverse x.
Hmm.
Tan inverse x, and have to integrate it from 0 to 1. This was example number 5. So we don't have any choice to select, because we are going to apply integration by parts. And we know that there is a formula. F of x, g of x, dx is equals to f of x, g of x minus integral of g of x, f dash of x, dx.
This is the same equation, VU minus integral of U dV, right?
Yes, this is the same.
Okay. Okay, can we use the other terms, V and U? Because in the class they use V and U, so I don't want to get confused.
Okay. U,
Okay.
V dash is equals to uv minus integral of v du. Is it better now
Okay.
for you?
Yeah. It's because the professor, he explains like this.
Okay. So we don't have any choice to. We don't even have to think that what should be our g and or what should be our u of x and what should be our v. So let's take this is our u, which is tan inverse x, and our d v, when v dash is dx. Now we need du, so let's differentiate it. We remember that when we were studying the inverse trigonometric functions, and we study some identities that the differential of tan inverse x is 1 over 1 plus x square dx.
Okay.
So it is 1 plus 1 over 1 plus x square dx. And we have to take the integral of it. So it will be v
It will
equals
be
to
x.
x. Yes.
Okay.
Now substituting it in the formula, it will be uv, u is tan inverse x and v is x minus integral of v, which is x, and then du, which is 1 over 1 plus x square dx. It's clear?
Yes.
Okay. And then
Until
we
now,
have,
clear.
okay, then we have limits. It says we have to integrate it from 0 to 1. So we have to evaluate our function from 0 to 1 like this. This formula of integration by parts will become a to b, because this is the limit, this is the lower limit, this is the higher limit, and it
Okay.
will be a to b integral of a to b. This is what I
Okay.
have done here. Is it clear?
Okay.
Okay. And then it will become 0 to 1 tan inverse x dx is equals to x tan inverse x evaluated from 0 to 1 minus integral of 0 to 1 x over 1 plus x square dx.
Hmm.
0 to 1 tan inverse x dx equals to, now we have to put our upper limit and then minus lower limit. So upper limit is x tan inverse 1. This was our upper limit minus,
Okay, so we have to substitute, right?
yes, we have to substitute our upper limit and then our lower limit. So
Okay,
it
so
will
then
be
it becomes 0 over 1 plus 0 square.
1,
Why?
because we are going to put 1 and 0 instead of x. So 1 tan inverse 1, 0 tan inverse 0. Is it clear?
Okay. Yeah,
This is
yeah,
upper
okay.
limit, this is lower limit.
Okay.
And then we have this function integral of 0 to 1 x 1 plus x square dx. Have you studied integration by substitution?
No, everything I studied is with you.
Okay. Because in this part, we have to use integration by substitution. So I'm just, going to tell you for now, but we will be studying this in very detail after completing this
Okay.
integration by parts.
Okay.
So, okay, do you have a calculator with you?
Yes.
Okay, tan inverse 1 will be
Tan inverse 1. It will become 45.
okay 45 or 45 degree or pi by 4 radian.
How is it 5 by 4?
Okay. Pi radian is 180 degree. That is the equation or conversion identity that we know. And we know that we have 45 degree.
Yeah, divide by 4.
Yes.
Okay.
180 divided by 4, so it becomes 45, and 1 radian will be
180.
180 divided by pi. Okay, and we have 45 degree. So 45 degree will be and 45 goes into 180 by 4 times, so we got pi by 4.
Okay.
Is it clear?
Yes.
and then we have minus sign, and 0 multiplied with anything makes it 0. So we have
Yes.
got, okay, and then we have integral from 0 to 1, x1 plus x squared dx.
So here we substitute 0,
Yes,
or we still
where
substitute 1.
here we have substituted 1, here we have substituted 0. 0 multiplied with anything makes it 0. So, and here we have got 45 by 4. And this is where I have wrote this function as it is. Is it clear?
Yes.
Okay.
Now I can draw. Okay, good. So I can, if there is anything, I will tell you.
Okay. Okay. We have
Okay, so
to,
just quick question. Can you go a little bit up, please?
yeah, sure.
Okay. So okay, so first time we do by 1 and then by 0, correct?
Yes.
Okay, so the first time this one is the same as this, right? We substitute these two, right?
No. This is our question.
Yes.
Okay. And then we substituted whatever our upper limit and lower limit into this function only.
Okay.
It's just
Okay.
like this. It's just like this. We have x square, and someone is asking me that I have to substitute it from 1 to 2. So I will write 2 square upper limit and then lower limit.
The lower limit is 1 square. Okay.
Yeah, the
Okay,
lower
okay,
limit is
I-
1, upper limit is 2. So I will first I will be doing for the upper limit, and then I will be doing for the lower limit. So whatever I
Okay.
have a variable, I will be writing that that limit into that function. Is it
Two
clear
times.
now?
One time 1, one time 0. Yes, clear.
Yeah. So it's the same function. For the first time, I wrote for 1, and the second time I wrote for 0. The same function.
Okay, so first we find the 1 plus. Okay. But why didn't we do for the 0? Because it's always 0.
You are asking me that why don't we do first time for the 0 and then for the 1? Is this your question?
Yeah, like
We have,
didn't.
we have to always start from the upper limit, and then we have to subtract it, and then we have to write down the lower limit. So it's always this way, upper minus lower limit.
Okay.
Okay. Okay, for this part, we have to again integrate it because we have integral sign.
Mhm.
Okay. Here we will.
So it's gonna be 1. Okay, continue.
Yeah.
Sorry.
Here we'll be applying again substitution method. So u equals to 1 plus x squared, and du will be, because I'm differentiating this function with respect to x, so it becomes du equals to the differential of constant 1 is 0
Plus 2x square.
plus 2x only.
Why? Okay, I thought this was cube. Okay.
No, it's x squared. So it's du 2x dx,
Correct.
and then it will become, if I have to find out x dx, then it will become du over 2 equals to x dx. I divided both sides of the
du.
equation by 2.
Okay.
Okay, so it becomes cancel out, x dx is equals to du over 2. Now can I substitute our u and du into this equation? I mean into this integral. So it becomes 0 to 1. X dx is du over 2. And 1 plus x square, which I assume that it's equals to u. Oh, it becomes. Is it clear?
No. Everything was okay. Everything was okay, but then after we finished, like everything below here, I didn't understand.
Okay, because we have applied from now onwards, we have applied integration by substitution. We will be studying this topic later after we complete our integration by part. So I'm just telling you, not in detail, but telling you that how we are going to solve this question further. So first we have to yes,
There are three types, right? Integration by parts, integration by substitution, and then integration, trigonometric integration, right?
Yes.
Okay, so this is the part I didn't study yet.
This is the
part I didn't study yet.
Yes, we are going to study
Okay.
after the integration by parts.
Okay.
Okay. So far now, we just know that u is equals to 1 plus x square, and du is equals to, because I'm taking the differential of it, so du is equals to 2x dx.
Yeah.
And then I need to find out what is x dx, which is equals to du over 2.
Okay, so okay, yes.
Okay, and then 1 plus x square, I just let it know that it's equals to u, so I just put u instead of 1 plus x square. Okay, it's pi by 4 minus, so pi by 4 minus, can I take the constant out? 1 over
Yes.
2 out, and 0 to 1 over u, du is left inside.
Why 1 over 2? Because du is 1.
1 over 2 is taken out, and what is left? Du over u.
No, but where did we bring the 1 from? Why isn't it just 2 outside, not 1 over 2?
Oh, it's the 2 is in the denominator.
Okay.
Yeah. Okay, let's find out the integral of 1 over u. This is the function that we have, 1 over x dx. We have 1 over u du. Okay, so it will be equals to ln x plus c. In our case, it will be equals to ln u plus c. Let's don't write c here. So it is from 0 to 1. So pi by 4 minus half ln 1 upper limit minus ln 0 lower limit. Okay, when I let it's 1 plus x square, then my limits it was for x1 and y x2. I have to change it in u1 and u2. So my u1 will become 0 square, which will become 1, and my u2 will become 1 plus 1 whole square. My u2 will become 2. My new limits after substitution will become 1 to 2. It's clear? And ln1 is, can you use the calculator and can find out what's the value of ln1?
0.
So ln2 minus 0 is ln2. So this is the answer. Pi by 4 minus ln2 divided by 2.
Okay.
Was this clear to you? Instead of, substitution method, because we are going to.
Yeah, everything until the substitution method I understood, and then I got lost.
Okay. Once we learn the integration by substitution, then we will come back to this question.
Okay.
Okay. Okay. Now let's solve. Some examples from the book. This is evaluate the integral using integration by parts with indicated choice of u and dv. Okay, so the question number 1 is that we have to take the integral of x e raised to the power 2x dx, where they have mentioned that what is x, what is u, and what is dv. So we don't have to identify ourselves that what is u and what is v. So exercise 7.1, and its question number 1 is integral of x e raised to the power 2x dx, and they have given us that x is u is our x and dv is e raised to the power 2x dx. This was the question that was given to us, and they have mentioned that we have to apply the integration by parts. So x e raised to the power 2x dx will be equals to du will be 1 dx. Is it clear?
Yes.
Okay. And now we have to find out the integral of e raised to the power 2x dx. The integral of dv will become v, and integral of e raised to the power 2x is e raised to the power 2x divided by 2.
Yes.
Okay. So it becomes, if we take the differential of it, it becomes 2 e raised to the power 2x, because we are multiplying whatever is in the power. We take its differential and then we multiply it. In the integral, it's opposite. Whatever it is in the power, we differentiate it and then we divide it by whatever the function is. That's the difference.
So like integration of x cube will be x square and divided by 2, right?
Integration of x cube will be x4 divided by 4, because we
Okay,
add
so
1 and then divide it. Divide whatever
okay.
it is by 4.
Understood.
Okay, and then we have now got u, v, du. So the integration by parts formula is v, u. So u is x, v is e raised to the power 2x divided by 2 minus integral of v, which is e raised to the power 2x divided by 2, and du. Du is dx. Is it clear?
Yeah.
Okay. So x by 2, e raised to the power 2x, taking constant out, which is half, it becomes e raised to the power 2x dx. And then it becomes x by 2 e raised to the power 2x minus half. Okay, again we know that what is the integral of e to x dx, which is
Yeah.
e to x as
It's
it is.
e.
Mhm.
Hmm.
e2x as it is and then divide by 2 plus c.
Why didn't we do like e 2x square? Because we have to add one more power.
Can you tell me here what you are telling, what you're saying?
Like the derivative, I mean,
Mhm.
like the integration of x cube will be x4 over 4, right?
Hmm.
Yeah, why doesn't the same concept apply to e to x?
Okay.
Like why? Yeah, okay.
Okay. When we differentiate e raised to the power 2x, what did it become? The simplest one is
E,
ex. The differential of ex is ex itself.
yes,
Okay. And now the differential of e2x is e2x as it is, and we differentiate 2x again. So it becomes 2.
yes,
So it becomes 2e2x.
yes, yes,
Okay. Now we are going to integrate the function e2x. e2x will be as it is. And then
we
whatever is
integrate
in
the
the,
power.
yes, we are going to differentiate the power now. But this time it will be in divide, not in the multiplication. That's the difference.
Okay.
Okay. That is something else. That was a power rule where we add or subtract.
Okay, okay.
And this is the exponential rule or the logarithmic rule. So it is x e2x divided by 2 minus 1 over 4 e2x plus c. Is it clear?
Yes.
Okay. Okay, let me check the answer. It's correct. So let's move on to the question number 2, which is square root x ln x dx. So u is ln x and dv is square root x dx. That u and v they have given to us. That which one should be u and which one should be dv. Is it clear? Du will be 1 over x dx and the integral of it will be v. Okay, now it is x raised to the power half. We will be adding 1 to the power because we are going to apply the power rule here and then divide it with the same power. So it becomes x 3 by 2 divided by 3 by 2. Is it clear?
No.
Which part is not clear to you?
Okay, after we finished after we found that d and du, the dv, I don't understand dv.
Okay. They have given us that what is should be u should be ln x and dv should be square root x dx.
Okay.
Okay, and then we find out that u is equals to ln x. So du should be the differential of ln x is 1 over x dx.
Yes,
Okay,
and dx is x.
dx is what?
X.
Are you talking about this?
No, the one that you just wrote.
Okay.
This one.
Okay. So the dv is square root x dx. So we have to find out v. So we are going to integrate it. So it becomes v equals to x. If I don't have to write square root, then it becomes half
Mhm.
dx. And now can we use the power rule of integration?
Yeah, it's gonna be
Okay.
1
So
over 2x
no,
minus 1 over 2.
that was a we were saying that the power first and then we subtract 1 from the power. That was the power rule of differentiation. It is the power rule of integration.
What's
Where
the
we
power
add,
rule of integration?
it is this. If we have x square, then we will be adding 1 to the power and we will be dividing with that same power. So it will be x3 over 3. If it's x4, then it will become x5 over 5. We have to divide with the
Okay, so-
same power, that is.
Okay, so in this case, what do we do? X1 over 2.
Yes, x1 over 2. So we have to add 1 to the power and we have to divide with the same power. Clear?
Yes.
Okay.
Yes, clear.
So half plus 1 will become 3 by 2 divided by 3 by 2. Is it clear?
Yes. Yes.
Okay. Okay. If I have to write this in this form, 2 by 3 x3 by 2, can I write it like this? I took the 2 in the numerator.
Okay.
Okay, so it becomes 2 over 3 x3 by 2.
Okay.
Okay, that is our v. That is our v.
Okay.
That is our u, and that is our du. So now apply the integration by parts formula, which is v du, which is 2 by 3 x3 by 2, and v u is ln x minus integral of u, integral of v, which is 2 by 3 x3 by 2. And then we have du, which is 1 over x dx. Clear?
Yes.
Okay. So it becomes 2 by 3 x3 by 2 ln x minus because I can take the constant out. So 2 by 3 is outside. Okay. And x3 by 2 over x dx. Is it clear? So 2 by 3 x3 by 2 ln x minus 2 by 3. Okay, x3 by 2. Can I take x power 1 to the numerator side? If it is power 1 plus 1, then it becomes minus 1.
Yeah, power 1 plus, yeah.
Okay. So it becomes 2 by 3 x3 by 2 ln x minus 2 by 3 integral of x. So it becomes 3 by 2 minus 1 becomes half dx. Is it clear? 2 by 3 x3 by 2 ln x minus 2 by 3. Okay, the integral of x half will become power 1 to the edge 1 to the power and divide with that same power. Is it clear?
Yeah.
Okay. So it becomes 2 by 3 x 3 by 2 ln x minus 2 by 3 x half plus 1 will become 3 by 2. over 3 by 2 plus c. So it will become 2 by 3x, 3 by 2 ln x minus 2 by 3. Can I write 2 by 3? I mean the one in the denominator. Can I take in the numerator side? So it becomes 2 by 3 from 3 by 2.
Yeah.
Okay, and x 3 by 2 plus c. So 2 by 3x 3 by 2 ln x minus 4 over 9. I just multiplied it, and 3 by 2 plus c. Okay, is it clear?
Yes. What types of integration we used here?
In this question, we have used integration by parts.
Okay.
So far, we have only
clear.
learned about. So far, we have only learned about the integration by parts.
Yes.
Okay, and then we use some basic rules, power rule, and yeah, in this question, we have only used the power rule of integration.
Okay.
Let's get back to the book and let's do this one. It is a little bit tricky. So it is x cos 5x dx. X cos 5x dx. Okay, in this question, they have asked us that to find out, to evaluate the integral. They haven't mentioned what is u, what is dv. In the question number 1 to 2, they mentioned us that what should be u, what should be dv. In this question, from now onwards, we have to identify ourselves that which one should be u, which one should be dv. So let's understand. We have already discussed that we can't take u as cos 5x because this function is never gonna end. Cos becomes sine, sine becomes cos, cos becomes sine, and it's irreducible function. So we are going to choose u as x, and our dv will become cos 5x dx. Is it clear? Okay. And then our du will become dx. Oh yes, du will become dx, and the integral of dv will become v equals to the integral of cos 5x is, I mean, the integral of cos x is sin x.
Minus
Sin
sign, I think.
That was the differential,
Okay.
which is minus sin x. In the integration, it is reversed. The integral of cos x is sin x. So it is sin 5x, and we have again differentiated, so it becomes sin 5x over 5. Is it clear?
Mhm.
Okay. Now it becomes u is x, v is sin 5x over 5, minus integral of v, which is sine 5x over 5, and du, which is dx. So x over 5 sine 5x minus 1 over 5, because that is constant, taking it outside. And we have sine 5x dx. Is it clear so far?
Yeah.
Okay. So x over 5 sine 5x minus, okay, the minus 1 over 5. The integral of sine x is minus cos 5x. Right?
Mm.
And we have to differentiate it again. X over 5 sine 5x minus minus becomes plus 1 over 5 cos 5x divided by 5, and then plus c of integration. So it becomes x over 5 sine 5x plus 1 over 25 cos 5x plus c. X over 5, yeah, that's the answer. Is it clear?
Yeah.
Okay. In the question number 4, we have to integrate the function, and the function is in the dy form. So y e raised to the power 0.2y dy. Okay. This is again a reducible function.
What is this 0? E.
You mean this 0.2y?
Yeah.
That is the that is given in the function. That is y e raised to the
Okay.
power 0.2y dy.
Okay.
So we have to choose our u as our reducible function. So our u becomes y, and our d v becomes e raised to the power 0.2y dy. Is it clear?
Mm.
So du becomes dy, and dv becomes, for integration, dv becomes v, and the integral of e raised to the power 0.2y is e raised to the power 0.2y as it is, and we have to differentiate it with respect to y. So it becomes e raised to the power 0.2y divided by 0.2.
Yeah.
Okay. So now we have to apply integration by parts formula.
Okay.
It becomes v, which is e raised to the power 0.2y divided by 0.2, v, and u, which is y, minus integral of v, which is e raised to the power 0.2y over 0.2, and we have du, which is dy. Is it clear?
No, yeah. Yes, kind of clear.
Okay. So it becomes y e raised to the power 0.2y divided by 0.2 minus taking the constant out, so it becomes 1 over 0.2 out e raised to the power 0.2y dy.
Hmm.
So we have y e raised to the power 0.2y minus 1 over 0.2. The integral of e raised to the power 0.2y is e raised to the power 0.2y divided by 0.2 plus constant. Is it clear?
Yes.
So y e raised to the power 0.2y divided by 0.2. 0.2 multiply with 0.2 will become 0.04. Okay, let me just check it out. Yes, it becomes 0.04 e raised to the power 0.2y plus c. Is this question clear?
Yeah.
Okay. Let's do one more question and then the question is that t e raised to the power minus e 3t divided by in dt. Question number 5 is integral of t e minus 3t dt. Can you from this question can you tell me that what should be our u and what should be our dv?
Does it? U should be the t because it's reversible easily.
Okay, so u should be t and
Yeah, and
D-
then dv. Yeah, dv will become e minus e to the power of minus 3t.
dt.
Yeah.
Okay.
Yeah, and then du will be just one.
Just one or dt.
One dt. Yeah, okay, it's the same. Okay, and v will be it will be e to the power of minus 3t over minus 3, I think.
Yes. Then integral applying the integration by parts, it will become
vu minus the integral of v du. So it's gonna be v, which is the first part, this one, e to the power of minus 3t. Okay, it's multiplied by t minus the integral of e to the power of minus 3 over 3 multiply by t, multiply by dt.
Okay.
Okay, and then
So-
these two we multiply them.
Okay, and then minus minus will becomes plus. So e minus 3t. I'm taking the
Why
constant
minus
out.
minus? Only one minus.
This minus and this minus.
Okay, okay.
So it becomes plus. I'm taking the constant out, so it becomes 1 over 3. Inside is left only this.
Wait, again. What do you mean taking the constant out? Like 1 over 3?
Yes, 1 over 3 taking out. And then inside is
Okay,
left
okay.
only e minus 3t dt.
Yes.
Okay. So minus t e minus 3t over 3. 1 over 3. And then what should I write? The integral of e minus 3t?
E minus 3t over 3t. I mean over 3. Minus 3.
plus integral constant C.
Why don't we integrate twice here?
We have.
Like
did the
here, what?
Mhm.
Okay.
First, we apply the integration by parts because there were two functions, u and v. Here we don't have
Yeah.
any function that we can say that this is u, this is v. We have only one function, that is e minus 3t.
What? Why can't we take like a minus 3t as u and then dt as v?
You mean u is equals to e minus 3t?
Yeah, and then
And
dv will
equals
be
to-
yeah.
Yeah, we can do that as well.
But
But we know the
it's
direct,
okay.
yeah, but we know the direct integral of e minus 3t.
And this is only one, so it gets cancelled. Okay. Okay.
Even if you want, we
Clear.
will be getting the same answer. Like du will be e minus 3t, minus 3 will be multiplied because we are taking a differential. And then
Mhm.
again, we have dv because that will be equals to t, right?
Yeah.
Okay, and then uv, which will be t e minus 3t.
Hmm.
Minus integral of one minute. Let's do this way and then see what we get. Integral of
Okay.
e minus integral of v du t, and du is minus 3 e minus 3t.
Now, which part are you doing? The first, the original one, or the second one you're doing?
We are doing this part.
Okay. Okay.
Okay. So it becomes t e minus 3t minus minus plus 3t e minus 3t in the integral of. So you can see that if we take u is equals to e minus 3t and dv is equals to dt, we again ended up with integration by parts. We got two functions here, which is t and e minus 3t.
Yes.
The function is even getting more complicated if we are going to do if we are going to use this method. Again, we are going to apply the integration by parts.
Okay.
So it becomes minus t over 3 e minus 3t minus 1 over 9 e minus 3t plus c. This is the answer. Is it
Okay.
clear?
Understood. Yes, clear.
Okay. Let's end it here, and we can do the same class. I mean, can we do this class on the same time tomorrow?
Tomorrow at 4 is better, if possible. If not possible, no. Okay, yani 3 will be a little bit hard, but I will try to manage.
Okay, because
But 4 is better. You have someone at 4?
I have at 4 your friend. What was her name? Hamda, I think.
Hamda, yes. Okay, خلاص. Leave her at 4. I'll do 3.
Okay.
Okay, tamam. Thank you.
Thank you.
Okay, can you send me these notes as well also?
Yeah, I'm sending you now.
Okay, tamam. Thank you.
Bye.
Bye.